what did we call it? The series. The trapezium rule, we mentioned it actually. And I gave some examples that day. We said the trapezium rule is simply using the trapezium, the area of a trapezium, the formula for the area of a trapezium. That is what the trapezium rule is using. And what is the formula? The formula is area equals to, we've always told ourselves that integral is an area, most especially if it is definite. A bounded integral, we told ourselves what a bounded integral is an area. So A, half of H, open bracket, A plus B. So if this is a thing now, so if these are different functions, let's say x1, x2, x3, x4, x5, like that, and this is, so the biggest one will serve as my yn, and the smallest one will serve as my y1. Then I'm going to say y1 plus yn plus 2 times all other y's that are there. So I've given the formula that area is equal to 1/2 times this h, which is going to be the width, open bracket, a plus b. So we gave ourselves examples. I'm trying to think of the example, but it's not here now. The last example we gave, is there anyone here that has it? Or we should just proceed? So I encountered an example in the material. That one was the integral is equal to from 1 to 3, the x over x squared. This is the integral. You're asked to evaluate this integral. You know the example I gave, they gave us the ordinate. They gave like -3, -2, -1, 0, 1, 2, 3. Now no ordinate here. No ordinate. You should be the one to create your ordinate yourself now. You don't have to stress yourself. It's not hard at all. Just make this your ordinate. It is from 1 to 3. So your ordinate is having the range between 1 to 3. That is the range of your ordinate. It is between 1 to 3. Now it is like this. I can make my ordinate 1, 2, 3. But this might not give me a full accuracy. So let me make my ordinate. That means if I'm making my ordinate this, then my h, which is the width, is going to be what? 2 minus 1, 3 minus 2. That is the common difference, which is 1. But if I made my ordinate 1, because it is starting from 1, I can never have less than that one. 1.5, 2.0, 2.5, and 3.0. It won't exceed 3 because 3 is the biggest. That is the boundary there. Now I have 5 ordinates now. 1, 2, 3, 4, 5. I can say that I have 5 ordinates now. This gives me more tendency to have a good answer. Then the width here, which is my h, is going to be what? My h here is going to be the common difference here. Is there anyone to tell me the common difference now? Anyone to tell me the h in this sequence you are seeing here? 1, 1.5, 2.0, 2.5, 3.0. So what is the height? What is the h here?
I think 0.5.
Very well, thanks. 0.5. So my h is 0.5 then. So I'm going to be using that out of the formula. I said my formula, the integral is equal to 1/2. Don't forget that we are using the trapezium rule now. 1/2 times the height, open bracket. How many ordinates do we have? 5 ordinates. So the first ordinate, y1, plus the function of the last ordinate, that is y1 plus y5, plus 2 times the sum of all other ordinates there. That is going to be what? y2, y3, and y4. That is the case. That being the case, we can solve that out now. But I don't seem to know my y1 yet. I don't know my y5 yet. I don't know my y2 yet, my y3 yet, and my y4 yet. So my y1 is going to be, come here. This is the function, the x over x squared, which is apparently I equal to 1 over x squared dx. The x is useless. You are not using it to do anything. That means the function is what? 1 over x squared. So y1 means my x will be 1, right? That is 1 over 1 squared. So y1 is equal to 1. What is y2? y2 means my x is already 1.5. So that is 1 over 1.5 squared. I don't know. Somebody there with a calculator. That is 1 over 2.25. So 1 divided by 2.25 is going to give me what? Anybody there? That is 2 point something, 0.2 something. 1 divided by 2.25. 0.2k. Just 0.2. Somebody
0.44.
0.44. Okay. 4. I can't hear you, please. 0.4 what?
4, like continuous.
Yeah, 0.44.
It is not terminating, so I'm going to take 2 of them. 0.44. So y3 is 1 over, what is the third ordinate? 2.0. That is 1 over 2 squared. That is 1 over 4. So y3 is equal to 0.25. y4 is equal to 1 over, what is the fourth ordinate? 2.5. That's 2.5 squared. So 1 over 6.25. So what is the value of this? 1.4, 0.14 something. 1 divided by 6.25.
0.16.
16 what? Down. So y5.
16.
y5 now, thank you. y5 means 1 over, the fifth ordinate is what? 3. That's 1 over 3.0 squared. That's 1 over 9. 1 over 9 is 0.11 to infinity. That being the case, we've been able to establish the value of y1 to y5. Now, my integral is going to be half times, we just call the common difference 0.5, right? 0.5, open bracket, y1. What is y1? 1. Plus, what is y2? 0.44. Plus 2 times y, sorry about that. 1 over 2 times 0.5, open bracket, y1 is 1. Then y5, sorry, I was saying y2. So y5 is 0.11 plus 2 times, open bracket, y2, 0.44 plus y3, 0.25 plus y4, 0.16. Please, somebody should add this together. I'll be having 0.25, open bracket, 1.11 plus 2 times 0.69 plus 0.16. That's 0.85. So I'm having 0.25. Your calculator can always help with this, right? Plus 1.11 plus 0.85 times 2, that's 1.7. So this is 0.25 times 2.81. We cannot do this one. Yeah. Somebody should calculate it for us. 0.25 times 2.81. This is 0.7 something.
0.562.
0.562. That is the value. 562. Everything. That is the value of the integral we have then. That means this is the value of the integral we have using this boundary using this ordinate. If we used an ordinate that is even more closer than this, we are having more tendency to have good answers. That being the case, this is trapezium rule. You might just be given the function this way, from 2 to 7, and the function is, dz all over open bracket z squared minus z raised to power 2. Z squared to power. Z squared minus z cubed. The question might come this way, and you are not given the ordinate. You know that this is 7. You can create the ordinate by yourself by having like 2.5, 3.0, 3.5, 4.0, 4.5, 5.0, 5.5, 6.0, 6.5, 7.0. That can be the case. So then we are able to achieve trapezium rule. Now let us look at Simpson's rule. Simpson's rule is also something not hard at all. In Simpson's rule, you are required to use 1 over 3 times. It also has its way of derivation, but I'm sure you're not interested. Sorry about that. So 1 over 3 times the width, that is h, open bracket, y1 plus y5 plus 4 times all other y's that are there. Finish. This is Simpson's rule. This is Simpson's rule, and this is trapezium rule. This is trapezium rule. This is Simpson's rule. We can apply trapezium rule to do some stuff. Definitely, we can also apply Simpson's rule in doing some stuff. Now, this is a problem that says I equal to b theta all over 1 minus 1 over 2 sine square theta, where theta ranges from 0 to pi over 2. Do you see now it's not very easy if you were someone that would just use the normal function method, normal integration method to integrate this value? Well, it's not going to give me an issue. But I don't know. That is why there is all these methods, or there are all these methods to use for it. That being the case, let's proceed with these and say my I is equal to this. So using the Simpson's rule, using the Simpson's rule for this, let's use it for something simpler first. The last example we did earlier was from 1 to 3. That is the x over. Let's use the Simpson's rule for it. So we know the ordinate is 1.5, 2.0, 2.5, 3.0. 1.5, okay, there is 1 too. The Simpson's rule is saying that the integral is equal to 1 over 3 times the width, open bracket, y1 plus y5 plus 4 times the all y's there. So that is y2, y3, and y4. This is Simpson's rule. This is Simpson's rule. And that is 1 over 3 times the width now is plus y1. I don't know my y1 now. My y1 is going to be, okay, I think we calculated it somewhere here. So let's just use those ones. Y1 is 1 and y5 is 0.11. So y1 is 1, y5 is 0.11 plus 4 times y2 is 0.44. Y3 is 0.25 and y4 is 0.16. So we can just use this formula now. That it is 1 over 3 times 0.5. That's 0. Okay. I will carry your calculator. I will come back to it. Open bracket 1.11 plus, I think we did everything here. So 1 over 3 times 0.5 is the most important thing now. Open bracket times 2. Times this 2.81 that we have here. So what we are going to do is this. What is the value? 1 over 3 times 0.5, please. 1 over 3 times 0. Somebody should just do that for us now. What do you say?
0.25.
0.5 divided by 3.
167.
0.67.
167.
0.167 times 2.81.
0.468.
0.468. In this one, we have 0.562. In this one, we have 0.468. If we use a different ordinate, like we had some ordinate smaller for this and have some ordinate smaller for this, then our answers will keep approaching the same thing. We'll be having approximately the same answers for both of them, even though they have different methods. So now let us now use it originally for what we are planning, and that is the integral equals to the theta upon 1 minus half sine squared theta. So to do this now, we are gonna have the, okay, let's say you are given to use 5 ordinates. Here you are given to use 5 ordinates between 0 to pi over 2. Who can tell me what to do? I suppose somebody is just going to waste our time. So the first will be 0, right? So the next one can now be pi over 8. The next one, pi over 4. The next one, 3 pi over 4. The next one, pi over 2. And that is the last one. So this is already 5 ordinates. Don't worry, assume I've formed this one now. How are you going to know the common difference? What is the common difference here? Which is the h? What is the h here? What is the common difference here? It's not hard, think about it. What are you going to add to pi over 8 to give you pi over 4? What is that thing? I'm waiting.
Pi over 8.
Pi over
8.
Pi over 8. Pi over 8 plus pi over 8. That is 2 pi over 8. And that is exactly the value. Pi over 8. So, how do you get that thing? Pi over 8 minus 0, that is pi over 8. Pi over 4 minus pi over 8 is pi over 8. 3 pi over 4 minus pi over 4 is pi over 2 minus pi over 3 pi over 4 is pi over 8. You can go and do it. This is it. Pi over 8, pi over 4 minus pi over 8. 8 is the LCM. 8. 8 divided by 4. 2. 2 times pi. 2 pi. Minus 8 divided by 8. 1. 1 times 1. 1 times pi. Pi. 2 pi minus pi. That is pi all over 8. So the h is pi over 8. Okay, we can just use the formula now. That the integral is equal to 1 over 3 times the h, open your bracket, y5, y1 plus y5 plus, plus open your bracket, 4 times y2, y3 plus y4. So now, what is my y1? My y1 is going to be, you're not going to show. So y1 is, that means we are going to represent this. You know this function, I've told you to remove this d theta. This function is the same as 1 over square root of 1 minus 1 over 2 sine square theta. So your theta are the ordinates now. So that is 1 over square root of 1 minus half sine square 0. Because this is the first ordinate, 0. This is 1 over square root of 1 minus 1 over 2 times sine square 0 is going to give me 0. That is sine 0 times sine 0. And that is 0. So here I'll be having 1 over square root of 1 minus 0. That's 1 over square root of 1. At the end of the day, y1 is equal to 1. So what is y5? That means using the fifth value. That is 1 over 1 minus 1 over 2 sine squared pi over 2. What is pi over 2? Pi over 2 is 90 degrees. 90 degrees. Pi over 2 is 90 degrees. Know it everywhere now. In radians, pi radians is equal to 180 degrees. Pi over 2 will be 90 degrees. Pi over 3 will be 60 degrees. Pi over 4 will be 30 degrees. It's like that. 2 pi is 360 degrees. So 1 minus half sine squared pi over 2. Because pi over 2 is the last value there. So pi over 2. So that is 1 over 1 minus half sine squared 90 degrees, right? That's 1 over 1 minus half sine 90 degrees times sine 90 degrees. That is sine square 90 degrees. Sine 90 degrees is 1. So sine 90 degrees times sine 90 degrees gives me 1. So here, square root of 1 minus 1 over 2 times 1. That's 1 over 2. So this is 1 over square root of 1 minus 1 over 2. That is 1 over 2. So now I am having the answer to the 1 divided by square root of 1 over 2. And that is going to give me square root of 2. That is going to give me square root of 2. I know you can just take your calculator to do something like this. Your calculator will definitely help you from this place. If you open your calculator for square root of 1 over 2, square root of 2, it is 1.4. That means y5 is 1.4. If we go for y3, y2, I'm going to stop at y2. You guys are going to do y3 and y4 for me. So y2 is 1 over 1 minus 1 over 2 sine squared. So what is y2? Pi over 8, Abi? Pi over 8. That's 1 over square root of 1 minus half sine squared. What is pi over 8? We know that pi is 180 degrees. So pi over 4 means 180 degrees divided by 4. And that is 45 degrees. Now pi over 8 is going to be 22.5 degrees. So you just need to say half sine squared of 22.5 degrees. This I cannot do with my brain. So 1 over 1 minus 1 over 2 times. So somebody should calculate sine 22.5 for me. Please, sine 22.5.
0.382. 0.383.
So yeah, square it. Square the value. Square the value.
0.618.
0.618. So divided by
8. There's 6 at the end.
You square. Did you square the value or you multiplied it by 2? Square it means multiply it by itself. Oh yeah, again. It's not 0.618. Sine 22.5. Open bracket. Write sine 22.5. Close the bracket. Square it. Are we together?
$0.146. The answer is 0.146.
146. So this is 1 over 1 square root of 1 minus 1 over 2 times 0.146. So divide that one by 2. Divide the 0.146 by 2.
73.
0.073. So now we subtract that from 1. So this is 1 over square root of 1 minus 0.073. I've got the calculator here. So that's 0.926. So the square root of that value is 0.962. So 1 divided by the answer. Everything here that we are doing now can be done by your calculator. So I'm having 1.038 as my y2. So now please, this is the function. Find y3 for me and find y4. I'm waiting, please. Find y3 and y4. This is the function. Pi over 2 to 0. 1 over square root of 1 minus half sine squared theta. The theta. So this is what you need to do. Use it to find y3 for me. The value of y3, the third ordinate is pi over 4. And if it is y4, the fourth ordinate is 3 pi over 4. The third ordinate is pi over 4. And the fourth ordinate is 3 pi over 4. Yeah. Are we together? Is there someone trying it? Or I should just continue? Is there anyone trying it? Are you guys going to give it a try? Please be responding. Is there anyone trying it?
Continue, please.
I'm going to try it, but down. So y3, we said from pi over 2 to from 0 to pi over 2, the theta over square root of 1 minus half sine squared theta. So we said these are the ordinates: 0, pi over 2, pi over 0, pi over 8, pi over 4, pi over 3, pi over 4, and pi over 2. So we got our y5, y1 to be 1. We got our y1 to be 1, our y5 to be 1.4, our y2 to be 1.038. Now we need to get our y3 and our y4. Now to get our y3, it is going to be equal to the third ordinate, that is pi over 4. So 1 over square root of 1 minus 1 over 2 sine squared pi, that theta, that is pi over 4. Haven't we used that? We've calculated, okay. Have we used, we haven't used it. So pi over 4 is 45 degrees. So the calculator now is going to be like this. 1 minus 1 over 2 sine 45 degrees is going to give me 0.7071. If I square that, I'm going to be having 1.4 or something. Yes. I'm not sure. Let's see. Sine 45. Okay. If I sine 45. 0.7071, yes. So the square of the value is 0.5. 1 minus square root half of 0.5, that's 1 over 2 times 0.5. That is 0.25. Now we are having 1 over square root of 0.8660. So this is 1 over 0.8660, and the answer is 1.154 as the value of y3. So what is y4? Y4 is going to be 1 over 1 minus 1 over 2 sine squared of pi. What is theta? Or y4, the fourth ordinate, that is 3 pi over 4. What is 3 pi? 3 pi means 3 times 180. We said pi is 180. So 3 pi is 3 times 180. That is 520. Right. 540. So 540 divided by 4 now. That is 135. 135. So 1 over square root of 1 minus half 0.70. So that's 1 minus 0.25. This is 1 over square root of 0.75. The same thing as the previous answer, 1.54 as well. That being the case now, we can come here and write the formula as integral is equal to the common difference, open bracket, y1 plus y5 plus y2 plus y3 plus y4. So this is 1 over 3 times the h now is pi over 8. You write it there, pi over 8. Open bracket, y1 was 1 plus y5 was 1.4 plus 4 times y2 is gotten to be 1.03. 1.54 plus y4. Please, are we together? If you are with me, let us know, please. Are we together? It's just a person, guys. 2 people. Okay. So, you're not in a stress. You are you together? You are you together? 5 over 24. You are with me. You are with me. 1 plus 1.4. That is 2.4 plus. So you know the calculator will always do all this for us. I've gotten a calculator here with me now, so I won't stress myself. This is 15.2. So plus this is 15.352. Now that answer plus 2.4, that's 17.752 all over 24 times pi. Now you have to be very careful. Your pi this time around is not 180 degrees. It is the normal value of pi, which is 3.14. So this one now divided by 24 times pi. That is giving us 2.323. That means the final integral after evaluating everything here is 2.3. So this is the integral, 2.323 as the integral, the final integral. Like after doing the evaluation, we're getting 2.323 and using that ordinate we used. So any question? That's all about Simpson's rule. Trapezium rule. Good. Go ahead. Go ahead.
Okay, yes. At what point does this pi change from 180 to
Speak up, bro.
3.14?
I can't hear you.
Hello.
Please speak up.
Okay, at what point does the pi change from 180 to 3.14?
The
Like, how
reason
do we
whenever
know?
you when in this life anywhere in the universe, whenever you encounter pi, that it is with sign. Pi is with sine, or it is with cosine, or it is with tangent, or it is with cosec. Anytime you encounter pi like that, know that they are not talking about the pi of 3.145 No, they are not talking about that pi. The pi they are talking about at that exact point is the pi of 180 degrees. But whenever you see that the pi is no more having sine something, it's no more sine pi. Here now we were using sine squared pi. Since the pi is being associated with sine, just know that it is not pi of 3.14, it is pi of 180. Now that it is no more associated with it, it is ordinary pi as 3.14. Is it clear now?
Yes, very clear.
All right, please, any question from anyone? That being the case, we are going to end the class here tonight. May God help us all and be our strength. Have a nice time. Thank you, kids.